So for this session, we will continue our journey into A-Frame, and we will talk about animations. And this will be the only chapter that we will cover today. We are, I think, advancing at a good pace, and so there's no need to push beyond this chapter today. And so this chapter is about animations. So animations are essentially a way of making things move in a kind of autonomous way. So we will see. I think you will find this interesting. You'll see that there are a number of simple but interesting things that we can do with A-Frame. Just a note to begin. Just to draw your attention, because you may, if you search for examples online about A-Frame and animations, you may find old examples that make use of a component, of an external component for animations. This was needed in earlier versions of A-Frame. Right now, we don't need any other external component for adding animations. Okay, so I just have this note in the beginning here because you may find older examples that still use this. And so you need to be aware, just so that if you reuse, if you adapt those examples, then you should remove the script from the top because it's not needed anymore. And so to add an animation, so imagine we want to make something move in the screen. To do that, we just need to add another attribute, which is called animation. And then in the value of that attribute, we will set up the animation. So we will say how we want the animation to proceed. So in this example here, in this very small snippet of code, so imagine we have a box in a given position, and we want the box to rotate automatically. And so to do that, we just need to add this animation attribute, and then the value, it follows kind of that syntax that we already saw several times before, where we add a number of pairs, a number of property names and values for those property names. And this is to set up the animation. So in this case, I'll just describe for now, and then we will see some of these properties in more detail. What we are saying here is that we want the box to be animated, but just a rotation of the box. So just a rotation characteristic will be animated. This is what we are saying with this property colon rotation. So this is saying, describing what property of the 3D object we wish to animate. And then we have the to property, and this is saying I want to animate the rotation of the box, which in this case, it has, in the beginning, it has a default rotation of 0, 0, 0, so it's not rotated. And here we are saying that the animation should rotate the box to this position, to this orientation. So we want the box in the final, at the end of the animation, the box will have this rotation. So 0 degrees on the X, 360 on the Y, and 180 on the Z axis. And we are also saying that we want the animation to last for 5 seconds. So this is shorthand for duration. And the time, so the duration of the animations in A-Frame is specified in milliseconds. And this is kind of usual in computers to tell the time in milliseconds. So for us, it's a bit weird because we are probably most often used to think in seconds, for example. but computers like they think mostly in milliseconds and even smaller units. But so we need just, if you think in seconds, just multiply the value by 1000 and you have the milliseconds. And so this animation, the box will rotate from 000 to 0360 180 in 5 seconds. So it will take 5 seconds to rotate. We are also saying here, and this is the last part, that we want to loop twice on this animation. So basically the box will rotate twice and then it will stop rotating. But we can make animations that last forever, and we will see that in a minute. Let me just show you the example so that you see the effect of applying a rotation. So this is what happens. The box, let me open this again. So the box rotates once, rotates twice, and then it stops. And so the properties I have just described, but they are again described here in the chapter. And we will see a few other properties with the following examples. So let me just, before we move on, just open the source code so that we see the complete source code for this example, just to show you really that, well, in this case, the scene is very simple, but also to show again that we don't need any external component for animations. So we just need to add the script for A-frame itself, and then on whatever primitive, whatever model, whatever object we wish to animate, we just add this animation attribute with that value that describes the animation. In this example, actually, I made a change here, so that I was just looping once and not twice. So we can change. Actually, let us, before we move on, let me make a copy of this and do some changes right now. So I'm going to add here a new file. I'm going to call it animation.html. I'm just going to paste the first example, which is a good example because it's very simple. And so let's make a few changes here and see the results. Let's preview now first to make sure that it's running okay and that we see the animation, and then let's make some changes. So the box here, it kind of seemed that it rotated twice, but that's because it's rotating on 2 axes, so it makes it harder to understand. But actually the animation just looped once. So I'm going to simplify things a bit. So let's remove the rotation on the Z so that it's easier to see how many times it rotates. And let's preview. So now it should just rotate once on the Y-axis. Okay, it seems. I think it seems okay. It's sometimes hard to see if you take your eyes off the screen. You have to imagine, and because the box is completely white, it's hard to follow the face. But I think it rotated just once. So let's add here. Let's make it loop twice to see the difference. So now once and again. I know it's twice. And also, I'm just getting ahead, a bit ahead already. This is in the chapter, but if we wanted an infinite animation, so an animation that doesn't end, we can just write here, instead of a number, we can just say loop through. This is a bit awkward, even for me, but this is just the way that A-frame is built. So you use loop through to make the animation go forever. And now the box should keep rotating and it will never stop. So it will make that 5-second cycle forever. Okay, and there's no point continue here. It will really go forever. And of course, let me make another change. We don't have to animate just the rotation. We can animate pretty much any property of our 3D object. So we could animate, for example, the position, and say I want the position here. The default, the initial position is 0, 1.62 or minus 2 meters, so it's in front of the user. But maybe we want the box to come towards the user and even go to the back. So maybe we can say that we want an animation that will take the position to the value 0, 1.6, and 2, for example. So it will be behind the user. And let's say we want this to last for 4 seconds. And let's keep the loop true. So it will keep appearing in front of the user and then going to his back. So now we have the box coming towards us, and then of course it disappears because it's on our back, and then it appears automatically in front of us again. So that's for the other cycle of the animation. And of course, if we move out of the way, we will see the box moving to the left and then instantaneously going back to its initial position. Okay, so let's move on now. Let's follow our chapter here. One thing that you may have noticed, let me see if it's, I'm going to put again on the rotation animation because I think it's easier to see. And I'm going to loop just once. I think in this, and I've even going to put it right back at the initial value. So a rotation both on the Y and Z axis simultaneously. And if you pay attention, I'll reload this once or twice. If you pay attention, you'll notice that the box seems, as it rotates, it seems to gain some speed. It seems to start slowly and then gain a bit of speed, and then it stops. Try to look for this. I'll reload. Yeah, it starts slowly, and then it rotates fast, and then it comes to stop. And that is actually happening. And so an animation can actually be kind of very different visually by just changing the speed of the animation along its way, along the sequence. So if the speed is not constant, we can make the object start slowly, accelerate, then end up slowly again, or we could start the object very fast and then make it slower and then maybe pick up speed again. So we can control the speed along the way, if you will, so along an animation cycle. Of course, we can. I didn't draw attention to this, but in response to the comment by Kimani, for example, we control the speed indirectly. So speed is kind of just distance over time. So one way to control the speed is to control the time. So we control the speed indirectly by changing the time that the animation takes. So if I want, for example, this box to rotate slower, I can say it will take 10 seconds. And now it will rotate much slower at half the speed. It will still start slow and then pick up a bit of speed, but it will never go as fast as in the previous example, because now the overall time for the animation is twice the time it was. So we control the speed through time. But so even for the same duration, we can change how the animation looks by changing how speed progresses through time. And this is done with a thing that's called easing. Usually in animation, this is called the easing. So this is another way to think of another name for this is just a timing function for that will control the variation of speed. And maybe it's easier to see before we see these values here. I'll show an example that I think illustrates well the differences. So what we have here, and this is not easy to see visually, but I'll show you in the code in a minute that all these 4 boxes, they have an animation obviously, but they all go from the same horizontal position to the same initial position to the same horizontal final position. So of course, vertically they have different values, but on the X, they all start on the same value and they end up on the same value. And what is probably weirder, it's harder to notice, but they also have the exact same duration. So it's not easy to see, but all the animations actually take the same exact amount of time. The only thing that is changing is this easing function, so the timing function that controls the variation of speed along the movement. And as you can see, it can have quite an impact. So just the easing can make quite a difference in how the animation looks. But I'm going to show you the source code so that you can verify what I was saying. So here we have all the boxes, and you see that they all start in the same x position. So x minus 3, minus 3, minus 3, minus 3. The only difference is the y position, so the vertical position. And of course, they need to have a different value. So 0, 1, 2, and 3. And if you look at the animation is equal for all of them except for the easing property. So we are animating the position during 5 seconds. Notice that all have a duration of 5 seconds. And the final position is the same. The X position is the same for all of them. So it's 3, 3, 3, 3 on the X axis. So basically the boxes will go they will travel 6 meters from minus 3 to 3 meters. And so again, the final position just changes on the Y axis. The only thing that changes is this easing function. And there are a few predefined values for this. So we have a linear easing, which says that the speed is always constant. So there's no acceleration or deceleration. Then there is an ease in out quad. The quad is not important. It's just the specific function that is used. But an ease in out just means that we start slowly, we gain speed, we progress at a rather constant speed in the middle of the animation, but then at the end we decrease speed again. So we start slowly and we end slowly. The ease out just means that we start at a constant speed and then at the end we end slowly, we decelerate at the end. And the last one is the opposite. So we start slowly, we accelerate, and then we end up at a constant speed. So this is the only change. And of course, the effect is this. So, so one thing that, and the default, by the way, the default, I think, actually, I'm not sure. I think the default is is in out. But actually, let me check this, because as you saw, when we did, if we don't specify an easing function, as we did in our first example here, the box still has variation in the speed. So the default is not the linear, but let me try to check this. And by the way, there are other names that you can use. They don't vary that much. So the main idea is this: you whether start slowly, accelerate, and then end up slowly, or just at the start or just at the end. But then they vary in the exact function that they use in how to accelerate and decelerate. Um, but so the default, let me see if I can find it here. Okay, here. Okay, yeah, the default is this one. So is in quad. So basically we start slowly and then accelerate and then end up at a constant speed. And so you should, when creating an animation, you should kind of try out different easings to see how they look, because they really can have an important impact visually on the result. So this is kind of the main takeaway. So don't worry too much about memorizing these values. It's really not needed. You can just go here to the documentation and see the complete list. It's just important to know that you can control this aspect of the animation. So how the object, how the speed changes along with time. Um, Another interesting thing that we can do with animation is kind of to what is called chaining, what I usually call chaining the animations. So what this allows us to do is to kind of create independent animations on different objects, but make them look like they are the same animation. And we just do this. This is done in a very simple way. So we just kind of synchronize the start of the animations in the various objects. So this chaining animations is simply this. It's just synchronizing the start of the animation. And for this, we need a new parameter, so a new property to control the animation, which is called the delay. Delay, you can think of the delay as the starting moment of the animation. Um, and so let me first show you an example visually, and then I'll describe the source code. So here we have, this kind of looks like a single animation. So we have three boxes, but their movement is synchronized. So I'll reload. So one box starts, and when this ends, the other one starts, and when this ends, the other one starts. So this kind of looks, it looks like they are interlinked somehow, but they're really not. So they are independent animations. Uh, it's just that the green box was made to start exactly when the red box ends the animation. And we just need to do the calculations for this, but we have to do them by hand, you know. And the same for the blue. So the blue box starts the animation when the green one ends. So we just need to calculate the values to make this happen. And so the way to do this is, well, actually, I think I'm going to show this in the source code. It's easier to show here. So the way to do this is just to add a delay. So maybe I'll do, to make it easier to understand, I'll copy this and make some changes. So I'll copy back to this file. I'll reuse this file, and then I'm going to first set a delay of 0 or null, so that we can see the differences. And so it's easier also to demonstrate how to calculate the delay to make it look like they are synchronized. So let's preview this. And now all the boxes should start growing at the same time. And so this is the default. The default delay is actually 0. So we did, if we want a delay of 0, we don't actually need to write this. But in this case, we will want different values. So we will leave the delay. So now let's say we want the second box to start the animation only when the first one ends. So what do we need to do? Well, we need to look at the animation for the first box and understand that this animation lasts for 1 second. So the animation for the second box should start 1 second after the animation for the first box starts. And so to do that, we just need to say, okay, the delay for this one is 1 second. So 1000 milliseconds. And so this way, the second box will only start 1 second after the, the, the first box starts animating. And so if we preview this, now the green starts only when the red box ends. And if we want to do the same for the blue, so the blue should start when the green one ends. So how do we do that? How do we calculate that? Well, we need to understand that the first box takes 1 second. The second box, the green one, also takes 1 second. So this will end at 2 seconds after the beginning after the scene loads. So here we need a delay of 2 seconds. And that's it. We just need to keep adding the values of the previous animations, of the durations of the previous animations, to synchronize animations on different objects. And of course, we could do this with a lot more objects than just 3, and this would even create a more interesting effect. So imagine you have those, so I don't know what, those kinds of effects where you see staircases appearing in front of the user, for example. You could animate each step in the staircase this way, so that each step would be appearing. It's like that the staircase would be appearing slowly in front of the user. And you could do this, for example, for 20 boxes, could simulate a staircase appearing, for example. So it's a kind of a very simple technique, but it allows you to do interesting things. So just a few other examples to show that they really don't introduce anything really new about animations, but again, just to kind of make it obvious what kinds of properties, of characteristics you can animate and how you can do that. So here I'd like to show again how you can try using nesting for animations. So in this, let me first, it's easier to show the example. So let me close these tabs that I don't need anymore. Imagine we wanted something like this. So let's concentrate first on the box. And again, I'm going to copy this source code to make it easier to understand what effect we are trying to achieve. So I'm going to copy this to my file, and I'm actually going to remove, for now, I'm going to remove one of the objects, which was a sphere that was rotating around the user. And so imagine we wanted to rotate the box, and I'm going to delete this also. Imagine we wanted to rotate the box. If we, oops, sorry, let me change here the position of this to make it in front of the user. put it in front of the user. And so we want the box to rotate. We already saw this, so I'm going to add here quickly the animation. And so we want to animate the rotation, and let's say we want to animate let's rotate that box on the z-axis, so it looks like the pointer on a clock. So 0, 0, and let's say 360, and we want it to take a duration of this is arbitrary, just 2 seconds, for example, and we want it to loop forever. What will happen is, what you see here is that the box is rotating about its center. And if this was to be the hand, the pointer, the hand of a clock, well, the hand of a clock shouldn't rotate from its center. It should rotate from one of the ends. It should also be rotating on the other direction, but that's another point. That's a smaller issue. But we wanted to make the box rotates about not its center, but one of the ends of the box, one of the extremities. So how do we do that? Well, the only way to do this is using the approach that we saw yesterday when we rotated the door to enter the house. We need to add an external entity, and then we animate that external entity. So I'm going back, I'm going to undo these changes and put back the original code of that example, just to make it quicker so that I don't need to rewrite everything. But so what we are doing here, and I'll show this using the inspector because it's easier to demonstrate. What we have here is this outer entity, which has the box inside. And look at first, when we select the outer entity, again, we can look at its center. So the reference point for the entity is this point here. And the box, notice that it is displaced from that center. So if we put this at 0, the box would be centered at the exact same point as the outer entity. So if I click one or the other, the center point, so these handles appear on the same location. But we don't want that. We want the box to be displaced. And in this case, the displacement is a Y displacement. So this was a kind of a tall box, and we just need to displace it by a quarter of a meter. That's because, let me see if I can explain this, because the height of the box is 0.5 meters, and so we are basically displacing it upward, and so we just need to displace half its height, which is 0.25. And so this will make the box be placed in a way that one of its ends is exactly on the reference point of the outer entity, so that if I rotate the outer entity, the box rotates about that point. So this is basically what we are doing in this code here. So we placed the box nested inside the entity, and then we animate the outer entity, not the box, because if we animated the box, it will still rotate about its center. So we want to animate the outer entity. And because it has objects inside of it, all the objects inside the outer entity will move along with the entity itself. So they will rotate with the rotation of the outer entity. And so this is the way to accomplish this kind of effect, an object that rotates not about its center, but about an arbitrary position. And in the original, let me go back to the original source code, and now I'll go back and add the snippet of code that I had removed. And maybe I'll replace so that we just have one object. This is the same approach now to make that sphere, which is rotating about around the user. So I'll move away so that you can try. We can try to see how it's rotating. So it's basically rotating in a circle, and now it's not around the user because the user moved, but it was in the beginning. It was around the user. So it's rotating in a circle, and the approach is exactly the same. So we create an outer entity, and then we displace the sphere that is actually the visible part. We displace it by 5 meters. And this displacement, in this particular case, it represents the radius of the movement of the sphere. So the sphere will have an animation, a radius of movement, which is 5 meters. So um, it will rotate with that radius. Um, and so this is the approach to get this kind of effect. And by the way, let me see if I can. Let me try to make a small change to make it this perhaps easier to see. Let's put the sphere rotating around the z instead of the y-axis, so that it rotates in front of the user. And now, of course, the displacement cannot be on the z. It could be, for example, on this is now it's not so important. It could be on the y or x axis. Oops, I made some mistake here. Let me see if I can find the mistake that I did. Maybe it's easier to. No, it's there. Okay, I don't know why I didn't see it. Is it the beginning? Let me reload. Oh, okay. So the position it's not okay. So we need to place the entity in front of the user. I always make this mistake. So because initially it was rotating around the user, so the position could be 0, 0, 0. But if I want it to be in front of me now, then I should displace this, for example, 2. And I'm going to lower a bit the radius of the movement, I think. Let's see, like this, if it's easier to see. Okay. Still not. I'm going to lower this a bit more. Just trying to make it. Oh, okay. There's another mistake. To make it really easy to see without the user moving. Let's center this on the eye level of the user. Okay, so now this is what I wanted. Something that is really easy to see. So now we have this. Let me try to do this in the inspector. And try to, for example, to scale the outer entity a bit on the y-axis. And so you see, well, it's not really easy to see actually. Let me see. It's not very easy to visually to see this effect. I'm going to write it here. So 1, 1, 2, 1 perhaps. So let's just try to scale this on the y-axis. Or maybe I'll try scaling it on the x-axis. Maybe it's easier to see because the screen, our screens are wider than taller. Okay, no, I'm not getting the result that I wanted. So I think I'm going to forget about this example that the point that I was trying to make, because it's actually not. I'm forgetting something, and I'm not getting the result that I expected. Okay, forget about this. Sorry, I'm missing something here, but um, this improvisation sometimes doesn't work as expected. So forget about that. This my last attempt, and just focus on this approach of um, rotating or moving about a different point than the center of the object. Okay, let's move on. And the other, I think perhaps kind of the last major thing to understand about animations is that we can animate multiple properties simultaneously. And of course, this is a bit, our source code starts to get a bit harder to read. But so it's something that we can do. It's possible to animate several properties at the same time. And the way to do that is kind of similar with the syntax that we already saw, which is by including several animation attributes, but then using this double underscore and giving each of them kind of a different name. So, and this name here, so this height, rotation, color, these are names that I chose. So these are names that are there just to differentiate different animations, and of course the name should have some meaning. And I chose height because this animation here will animate the height, this one will animate the rotation, this one will animate the color. But so the names are whatever you want. You could call this ABC 1, 2, 3, wherever. But of course you should use more meaningful names like these ones. And so by repeating these attributes, then with a proper name in front of it, we can just repeat the animations, and we can animate different properties, including color. So I didn't mention color, but color is also animatable. And you can give different durations and of course different values to each of these independent animations, and even different number of cycles. So for example, the height of the object is animated only once, but the rotation is forever. So the object keeps rotating, but it grows initially and then it stays with that height. So let me show you the example. So it grew a bit. I know it was a bit fast. I'm going to reload. So it starts as a cube. It grows a bit. It gets a bit taller, and then it keeps rotating, and it keeps changing color. So just to show that we can have different properties animated. Another property that I didn't mention before, but this is something that you can try then to investigate by yourselves, is that we have another property that we can control in the animations. Particularly, this only makes sense for animations that have multiple sequences, so that have a loop which is greater than one. like 2 or an infinite number of loops. And in that case, you can tell the animation to go back and forth instead of kind of looping instantaneously to the original, to the initial value, because that's the default. If you remember the first, let me try to make this more concrete. I'm going back to the first example. I was trying to describe animations orally. It's not very easy. So I'll go back to this example, which is very simple. I'm going to put it back here. And I'm going to put here a loop of, true, to make it loop forever. And I'm going to reduce this to make it quicker to see. And let's rotate on the Y only to make it easier to see. So now we have a box that rotates, and it keeps rotating. Actually, let me make another change to make it to make this more obviously useful. So let's, instead of animating the rotation, because in this case the rotation is 360, so it will the end position for the rotation is actually equal to the initial position of the rotation. So let's animate the position and make it go to let's start with an x of -2 and go to an x of 2, 1.6 and -2. So the box will just move from left to right in front of us. And when it gets to the end, it jumps. You notice that it jumps instantaneously to the left side. But maybe we don't want this. Maybe we want the box to keep going back and forth. To do this, we can just use the dir. This is shorthand for direction, and use a value that is here in this example. We can use a value of alternate. And actually, I'm going to show you the other possible values. I'm going to open the documentation for the animation. And if we look at the dir, you know that it can be normal, alternate, or reverse. So I'm going to show you these values. So let's first put in alternate. So this will just keep alternating between moving forward or backwards. So and the other one was so the default is normal. The other one was reverse. So let's see what reverse does. And well, it's kind of obvious. So it kind of inverts the animation. So instead of starting from the beginning, the box will start from the end. Of course, we could do the same thing by changing the start and end values instead of the direction, but just another way to do things. But so the alternate is probably the one that's most useful in many situations, because it allows the animation to go back and forth instead of kind of looping around and going back instantaneously to the beginning. And there are, of course, I'm not covering everything here. There are a few other properties of the animations that you can and should look for in the documentation. Just one quick notice for the color. If you want to animate color, then you need to use this format. So this hexadecimal format. You can't, at least you couldn't in the last version of A-Frame, you cannot animate colors if you give them names. So if you use color red, then you cannot animate. You need to use the hexadecimal version of the color instead of its name. The last thing that I want to cover, this will be the last part, almost finished, is how to make animations interactive. So kind of make the bridge between animations and the interactions that we saw yesterday. So again, this is something that is, I think, simple to implement, but can really achieve interesting effects. So what it means to have interactive animations is that we can trigger an animation from an event, from an interaction event. So all the previous examples that we saw, the animations were triggered um, by the load of the scene itself. So the scene started and the animation started. They could, of course, have a delay, and you could even you could even use a very large delay. So, for example, so that an animation only started 1 minute after the user entered the scene, but the trigger is still the start of the scene. You know, the moment the scene appears to the user. But there's another way to start animations where they start when the user does something specific. For example, when the user clicks a box, for example. And to do this, we need to use the start events. So this is again a property of the animation that tells what is the event that is going to start the animation. And I have a few examples here. So in this one, for example, actually I'm going to open this in a new tab. So in this one, the red box animates when the cursor enters. So if the user was in a mobile, in a smartphone, he just had to look at the box. On a desktop, of course, we can just move the mouse, just like we saw yesterday. And on the yellow box, the animation starts when the user clicks. Okay, so now we have a way to trigger animations depending on what the user is doing in our scene. Um, and for this, we just need to use start events, and the name of the event is the same. Um, uh, for the mouse events, at least the same names that we saw yesterday. So mouse enter may be a good event to use. The click may also be a good event to use a more explicit user action. Um, there is also, I'm just going to mention this because I don't think it's that useful, and also because in my experience A-Frame doesn't implement this very well. Uh, but there are also pause events. So we can also tell the animation to stop when the user does something. I'm going to show you, but again, this is not, in my opinion, very useful. So now we have an animation that starts with a click and that pauses when the mouse leaves. And so we can, if we leave if the mouse leaves the object, then the animation pauses. Um, it may be useful in some particular situations. If you have a very long-lasting animation and if the user just goes away, maybe you don't want the animation to keep running. Um, but otherwise, it's not as useful as other things. Um, there's also resume events, but it doesn't work correctly in A-Frame, so I don't advise you to try this. The last example that I want to show you is that um, different components, different external components, they may trigger different events, different from the ones that we saw about the mouse events, for example. Um, and just like we saw yesterday that we could make the door open automatically with that proximity sensor because it kind of emitted a proximity enter event. And yesterday we used the event set component to make a change, an instantaneous change. But now with an animation, we can make it even cooler by using the proximity sensor as a trigger for an animation instead of using event set. So now the user approaches the door and the door opens automatically, and it opens smoothly, so it's not instantaneously. So it's much nicer for the user, to see something opening up, and it closes behind us. So also with an animation, let me see if I can demonstrate this. So it opens. I'm going to move backwards so that we can see the door closing when we get out. Okay, so it opens and closes with an animation. And the only change to the source code that we had yesterday is um, is here. So instead of using an event set like we did yesterday, we just use an animation. Because we want an animation to open and another one to close, we have two. So an animation open and animation close. And of course, the property is rotation. We decide where the door should stop uh, opening. And then the important part is this. So the start events is the event is the proximity enter event, which is actually triggered by this component. So without this component, there is no proximity event. So we need to add also the component to that entity. And we can close the door with the proximity exit component. So this kind of shows, I think, a number of different possibilities for making not only things move, which move and slowly or fast, but move progressively instead of instantaneous, which is very important in an environment, but also make things react to users' actions with animations. And this is it. So this chapter, as you saw, is a bit smaller, um, but I think it's best for us to stop here today, because now you should start dedicating more time to thinking about your project and thinking about how you should use these kind of things in your own project. So you probably need more time. So I'm going to stop right now. I'm going to ask if there's any questions, anything that is not clear